Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding. Today we are going to work upon a lead code medium problem, product of an array except self. This is a really interesting problem, and so let's understand the problem statement. We are given an input array of integers and we need to return an output array that shows that every single element or every single uh, indices in the answer array is the product of all the other elements in that particular given input array. So let's take this current example. We are given an input array of values 1, 2, 3, and 4. And whenever we check the output array, we can see that the for the position number 1, we need to return the product of these three values. So what is the product of these three items? It is going to be 4 times 3 times 2, 24. For the second indices, we need to return the product of first and third and fourth value, which is going to be 12. And same goes for the third indices. We are going to return 8, and for the fourth one we are going to return 6. Now one important thing to note here is that we cannot use the division operator to get the response. If we were to use the division operator, the problem would become really simple. Basically, what we can simply do is we can, whatever the input array we are given, 1, 2, 3, 4, we just take the product of all the elements, and which comes out to 24. And in the response, in the output array, we can simply start dividing the answer with given uh, input value. So for the first one, if we divide 24 by 1, we get 24. If we divide 24 by 2, we get 12, and so on and so forth. But we do not want to use it. Again, keeping up with the custom, we are going to start with a brute force approach, and let's see what the brute force approach is going to be in this scenario. So for the brute force approach, we can simply take every single element and make all the make every single pairs. So for item number 1, we can just simply iterate over the remaining portion of array, and we can just take its product. So 2 times 3 times 4, and we will get 24. So we can put this in our output array. For the second value, we would again do the same thing. We would go for the first value and we would take the remaining two values and we will just simply do its product, and we will come up with the value 12. And we would be able to find the response, and this solution would work fine. But the issue with this solution would be that we would be solving our entire algorithm in big O of n square time. This is a really bad solution. So let's see if we can work on some optimization. Say for an example, we are given an input array like this, 1, 2, 3, 4. Basically, any single element in this array represents one thing. If we want to take the product of it, basically the entire product of the left portion of that given value and entire product of the right portion of given array, except the element that we want to check on. So let's see how it is going to be. If we take the example of item number 2, the first indices, it is going to represent. So on the left portion of 2, we only have one element, and the product of this one element is 1. And on the right side of this given value 2, we have two elements, 3 and 4, and the product of 3 and 4 is 12. And if we do the product of left side product and right side product, we get the value 12. And let's take it with another example. If we try to do it with 3, In this case, if we take the left side of the things, we would see the values being 2 times 1 equals to 2. And if we take the right side, we only have one element, so it would become 4. So what would be the product of array except 3? In this case, it is going to be 2 times 4 equals to 8, and this would be our answer. Okay, now let's continue with our example. 1, 2, 3, and 4. This is our input. Now let's create a prefix array. And what prefix array means? Prefix array means that for any given element, we are going to take the product of all the elements left of it as the prefix value, and we are going to keep adding in the prefix array. Now for the first element, on the left of first element, we don't see anything. So temporarily, we can consider that over here, it is 1 as the default value. The product for first element would be 1. Now what would be the product for the second element? Prefix of for second element would be the multiplication of first element, and in this case we only have 1, and since 1 times 1, it's going to be 1, so we can also add it here. Now for the third element, for this 3, we need to take the product of all the values that are before 3, which turns out to be 1 times 2. So 1 times 2 comes out to be 2. So for the third value, we can say that for third value in our given input array, the on the prefix we have the product as 2, and for the last one we will have the prefix as 2 times whatever we had for the left subtree times the previous element 3, and which is going to be 6. This is our prefix array. In the postfix array, we are going to do the same things, but we are going to do it in a reverse order. Again, for our postfix array, now we can say that on the right side of 4, we don't have any element, so we can consider it as 1. If we consider as 1, we can simply say that on the right side of the last element 4, we only have 1 because we don't have any other element that where we can calculate its product. So we are simply going to put 1 over here. For the third element, what is the product of right side array or the postfix array of 3? So we can see over here that we only have 4 times 1, so we can simply add 4 over here. Now for the third element 2, it would be 3 times 4, which would become 12. And for the first value, whatever the right side of 2 is, which is 12 multiplied by 2, which comes out to be 24. And now and in the output array, and we are going to do multiplications of those two. So the first element in an output array would be product of these two values, which becomes 24. For the second value, we take the product of both the second elements, and it turns out to be 12. And for the third one, we get 8. For the fourth one, we get 6, which is exactly correct answer. So if we calculate the overall time complexity, the overall time complexity of this approach becomes big O of n. And if we see space complexity, the space complexity also becomes big O of n. But the problem over here is that though this solution is perfectly fine, we still have room to optimize our solution. And how can we optimize our solution? If we look over here, we are essentially using prefix and postfix to store two separate arrays. So let's see the most optimal solution. We can just create our output array, and in the output array we can simply store the values of prefix and postfix at the same time. And first we are going to fill up all the values with by doing one traversal on the input side and towards the input array from 0 to n minus 1, and we will calculate all our prefix values, and we will start filling up our prefix values on the like this, some values over here, and we can do a second traversal on our input array in the reverse order, and we start calculate the postfix values, and we simply multiply them with whatever we have stored in an input array that already has the prefix values. Let's do it through an example so it would make more sense. As we already established that we would consider that on the left side of an array the value is 1, and on the right side of an array the value is 1. For the first value, we are traversing from left to right, and we are calculating the prefix values. So what would be the prefix of value number 1? It would be 1. What would be the prefix of value number 2? It would again be 1. What would be the prefix of value number 3? It would be 2, because 1 times 2. And what would be the prefix for 4? It would be 2 times 3, so 6. And now we have completed one traversal, and we have filled up our output array with prefix values already. And now we are simply going to do a reverse traversal. So let me just take the same input array. So the product for the rightmost element in the given input array would be whatever we have in the prefix times 1. So our value would be 6. Is number 3. What we are going to do is we are going to take whatever is left of 3, which is our prefix that we have already stored here, times whatever is on the right side, and on the right side we have 4, so we are going to do 4 times 2, so our answer would be 8. So on the right side we know that we have 4 times 3 equals to 12, so we are going to multiply 12 with whatever the prefix value we have. And for the last one, we have the prefix as 1, and the postfix values are going to be 4 times 3 times 2, 24. And this works out well. We get our desired output array. Time complexity, as we already mentioned, it would be big O of n. And space complexity, actually we are not storing any additional space for the given input array, because anyways we would have to create an output array to return the response. So to run this program we don't have to consume any additional space, so we can consider the space complexity as big O of 1, and this would be the most optimal approach. Now let's work on the coding solution.
Okay, we will start coding by first creating an output array of size of whatever is the input array given, and we are going to fill the entire array with the default value of 1. Now we will define a variable. We name it prefix, so for simplicity, and define its value as 1. And now we will iterate over the given input array. During this iteration, we are going to do two things. First of all, we are going to assign the value to results as the prefix, and we will update the value of prefix. Now we will do a reverse traversal for the postfix calculation. So first we define a variable postfix. We run the traversal in reverse order. And now we update the value of result. Notice here that we need to multiply with whatever value we have of prefix with postfix value, and that is what we are going to do. And we will update the value of postfix as well. Now we simply return the result array. Okay, looks like our solution is working. Let's try to submit it. Yeah, our solution works pretty fast and it is completely accepted. So this was a really interesting problem to learn. Hope you liked it, and leave a like and comment on which programs you want me to do again.